So I'm going to go ahead and draw ABC and then DEF. So A, B, C, D, E, F. So again, they told us the length. So AC is 6, AB is 9, BC is 12, and then DF is 2, DE 3, EF 4. So because they gave me a similarity statement to verify, this is going to tell me what matches. So let's match. So I need to match AB with DE. So AB is here and DE is here. Now, the way I wrote it, if I wanted to get a scale factor, I would do right over left. So DE over AB, and I need to put that into a ratio and then simplify it. Then the next two letters could be BC matching with EF. BC is 12, EF is 4. So if I write it in my ratio, EF over BC, 4 over 12, also reduces to 1 to 3 or 1/3. And then lastly, I can go ahead and grab the last side, which is beginning to end here, beginning to end. So I am doing AC with DF. So DF over AC, 2 over 6, 1 to 3. Since they all simplify to the same ratio, and I can show my proportionality statement, I could put DE, let me do it in the same color here. I can do DE over AB is equal to EF BC, and then DF over AC. Because all three sides are proportional, I can say that yes, these are similar by side, side, side. And again, this was the similarity statement that they gave us at the beginning. Okay, so if the question asks for a statement of proportionality, then you have to put the letters.
But like for this one, it didn't.
Right, it just said to verify it. So then you just had to put it 3 over 9, 4 over 12, 2 over 6, and simplify it. All right, and then if it asks for the reason is side, side, side. Let's try the next example. So here it says, show that the triangles are similar. Write a similarity statement and explain your reasoning. So the explanation is going to either be AASSS or SAS, or that they're not similar. Okay, so again, explaining your reasoning would be showing the work, showing the proportions, showing the congruent angles. Okay, so again, I've got a pair of congruent angles here. So I can first state that angle B is congruent to Y. And then I'm going to check my proportional sides. This time I don't have a similarity statement to go off of, but what I can do is go off of the sides of the triangles. So the side here, the 30, is the smaller between 30 and 45. So I'm going to match XY with the smaller side in the triangle ABC, which is 40. So XY over AB, 30 over 40 reduces to 3 to 4. Then the other side, the larger side, 45 and 60 will match. So YZ over BC, 45 over 60, I can divide them both by 15, and it also simplifies 3 to 4. So the reasoning would be that angle B is congruent to angle Y, and that XY over AB is proportional to YZ over BC. So we could say, yes, they're similar, and the reason would be side, angle, side. And the the similarity statement could be triangle XYZ is similar to A, B, C. And either way, they're both alphabetical. That is it for the warm-up. Now, I'm going to go ahead and just cover the 8-4 notes. And then at the end, I'll take any homework questions that you may have had from 8-3. That way, anybody who got all of 8-3 right, you'll have time to start your homework for 8-4. Anybody who struggled now with 8-3, I'll answer those homework questions for you at the end. So let's go ahead and get right into the 8-4 notes. This is the last section of the chapter, more proportions. So we're going to learn a couple more theorems and how to set up some additional proportions to find missing pieces of our triangles. So the first additional theorem is called the triangle proportionality theorem. And this one states that if a line parallel to one side of a triangle, it's going to intersect the other two sides, and then it's going to divide the two sides proportionally. So you need to be given that you have proportional sides here, parallel sides here, and then what it'll do is break up the other two sides of the triangle proportionally. Now, the way that this was set up, this is the top of both of the triangles, and this is the bottom of the division here. So this AB is going to be the top right side over the bottom right side, and then we're setting that equal to AE, which is the top left, over ED, which is the bottom left. Now, if you'd rather just do, see, we've been trying to stay consistent and do right over left, or right first and then left. You could have also put AE over ED equals AB over BC. Notice that both letters on the top come from the top part here. And then both of the letters down here come from the bottom section. Now, we could also go right to left or left to right. It doesn't matter as long as you stay consistent. I think what it might be better to think about is think about putting the tops in the top of the fraction and the bottoms in the bottom of the fraction. That might be a logical way to set this up. But technically, we could still also do right over left. So I could also do AE, just to make sure that you're aware of this. You could also set up your proportion as AE, the left over the right, so over AB, and then the bottom left, ED, over BC. So if you want to do left over right, you can also do that. Just be aware that you have options here. Think about this. These are actually two similar triangles. So if you think about the top one here in blue, the AEB, compared to the whole thing, the ADC, since these sides are parallel, I know I have corresponding angles going on. So I could say that D and E are congruent, as well as the reflexive A that they share. So I know these are similar by angle. So then again, I could use all of this same information for proportions that I already learned. But again, I think it's easier if we do top over bottom, and then it makes sense. Now again, you have options. You could do left to right. Just stay consistent so you don't get confused. Let's try the converse of this. The next slide has the converse of the triangle proportionality theorem. Remember, this switches the if and the then. So now what they're going to tell you is that if we've got proportional sides here, then we can prove that these two sides of the triangle are parallel. So if AB is proportional, AB over BC is proportional to AE over ED, then the sides are parallel. Now again, if you want to do, this was top over bottom. So again, this was all the tops. These were all the bottoms. Again, I could also do it left to right, or think of it as side to side. So what we could have also done is AE over AB, and then ED over BC. So again, the same thing I wrote last time. Again, this would have been left over right. So left top over right top, and then this would have been left bottom over right bottom. Again, just pick a method and stay consistent. Again, the more logical thing I think would be top over bottom. But again, it's up to you. Now let's try some examples of these two theorems. So they want us to complete the proportionality statement. They've already started it for us, so we need to match. So they've put CD, this bottom piece, over the top piece. Now, before I told you to do top over bottom, you can also do bottom over top. Just stay consistent. So since they started it for us, this is from the bottom, CD, over the top. So we need to pick the bottom over here, which was CE, over its top, EB. Now let's try and fill in or answer part B. So let me go ahead and erase this. And let me add in the numbers here. So for part B, I'll do in blue. So CD is 3. DA is 6. DE, this one right here, is 3.5. Let me do it in another color so it shows up. Let me do it in white. I'll do it in black. This is 3.5. And then they want us to find AB. So for this question, it might be better if you pull them apart because, again, they are similar triangles because we do have parallel sides here. So, again, I would have corresponding angles to show and as well as the reflexive angle C. So, again, I'm going to pull these apart. So I'm going to pull this little one down here off the bottom. C, E, D. And I'm going to label the sides that I have. This one's 3. This one's 3.5. And then I'll do the whole thing, the ABC in purple. Now, to find the length of AC, I have to add 3 plus 6. So this is found by adding 3 plus 6, and it's 9. And then this is what they're asking me to find, is AB. So what I need to do here is set up my proportion. So again, I can match my sides. And again, I could put 3 over 9. So again, I could take the CD with the CA. So this is for part B. I'm going to do 3 over 9 is equal to 3.5 over X. Actually, let me do it right to left. Sorry. Let me fix that. Let's do right to left like we're used to. Now, if you would have drawn the purple one first, then your right to left would have been different. So let me leave that there. So if you would have drawn the purple one first, that would have been your proportion. But I'm going to do it for mine. My purple over blue equals purple over blue.
Wait, this chord.
Yes.
What did you? Oh, never mind. Okay, never mind.
Okay. When I go to solve these, if you want to simplify this ratio first, you can, or you could work with it as is. So let me do the one on the left. I'm going to work with it as is. I get 3x equals 31.5, divide by 3, and x equals 10.5. If you reduce this, it makes it a little bit easier. And for some of you who are struggling to divide decimals, I would have definitely reduced that fraction since you're not using a calculator. So this way, all you have to do is 1 times x, and then just multiply 3 times 3.5, which automatically goes right to 10.5. So definitely you might want to simplify the ratio before you start to solve the proportion. When you're simplifying here, you can't simplify diagonally. You have to simplify the ratio itself. So this is how I can find the length of AB by using either one of the proportions. So AB is equal to 10.5. Now the numbers are changing, same picture. So now I'm going to do part C. I'm going to go ahead and label my picture now in red for part C. So CB, the whole thing here, equals 12. And then EB, this little part here, equals 8. Then CD, which is this little piece here, is equal to 6. And then they want me to find DA. So maybe let me just quick redraw this, just so it's not so busy. So B, A, C, E, D. So again, the whole thing here was 12. This was 8. So I could also just do 12 minus 8 and see that CE here is 4. And then this was 6, and I didn't know this. So just by doing 12 minus 8, that gave me the length of EC. And now I can use one of the proportions that I just learned. I don't need to separate them. You can if you want. So to find the length of AD or DA there, I'm going to do top over bottom. So I'm going to do top right over bottom right is equal to top left over bottom left. That's how I'm going to set up my proportion. So I can do x over 6 is equal to 8 over 4. And now I can cross multiply for x. Now, again, you can simplify it. First, I'm going to do it without simplifying. Divide, x equals 12. Or I could have reduced this fraction first, which you might want to do, since you're not using a calculator, reduce it to 2 over 1, and then it'll go right to your answer. So either way. Now, technically, I didn't have to do right over left or right on here and then left over here. I could do left to right and still get the same answer. So I could have also done 8 over 4 equals x over 6. I'm still doing the same cross products. You can also go side to side. If you want to go left over right, again, just stay consistent. So here we were using the proportionality theorem. Next one, new theorem. Okay, so for the next one, again, don't memorize the number. This is called the 3 parallel lines theorem. And this one states that if 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. So again, same idea here. We can still do both of these numbers are coming from the top section, which is this right here. And then these both are coming from the bottom section. So again, we can do the same thing we just did when the figure was a triangle. We can still do top over bottom. So notice this is BC, this one here, over its bottom, and then over here, this top, AF, over its bottom, FE. Now again, if you'd rather set it up as the left side, the AF over FE, and then the right side, you're still multiplying the same thing. You're still doing the same cross products. You can also, again, do left to right. So if you'd rather do AF over BC, you could do FE over CD. Again, pick something and stay consistent. I honestly think this might be the easier way to memorize it because it's logical. Top of the fraction gets the top numbers, bottom of the fraction gets the bottom. So let's go ahead and try some examples for these. So for this one's either or. So again, we're using the 3 lines parallel theorem, or the 3 parallel lines theorem. So again, let's add in the numbers into my diagram. Let me go ahead and redraw this real quick for B. Or actually, I'll do A right up here in this section in blue. I'm going to do A in blue. So let me label the picture. So if A equals 2 and B equals 3 and C equals 5, find D. So again, let's just set it up, top over bottom. So, and again, we could do either left over left and then the right. So if you want to do it just like you're reading it, or let's just do it consistent. Let's do right and then the left. Nothing to simplify, so let's just cross multiply. So 2 times D, 5 times 3, divide by 2, and D equals 15 over 2, which simplifies to 7.5 as a mixed number, or as a decimal, 7.5. Some of you don't understand tens place. The 5 is in the tens place of this number. If it said to round to the whole number, then this answer would have been 8. All right, now let's do part B. I'll do it in red. So let me just quick redraw this thing just to make it a little bit easier to see.
Miss Corey, can we go back to...
All right, so now part B, I was redrawing it. I'm not Notability, so my lines aren't very straight here, but you guys get the idea. So this one's parallel. I need a third one in here. Okay, and then it's divided with an A, a B, and then a C and a D. All right, so for B, it's telling me that A equals 4, B equals 8, C equals 5, and they want us to find C plus D. So again, we can do the same thing. Let's just do top over bottom. So I can set this up as 5 over D equals 4 over 8. If you'd rather do 4 over 8 equals 5 over D, you can do it with the left numbers first. Again, you probably want to simplify the 4 over 8, make it 1/2. And now we can cross multiply. D times 1, 5 times 2, D equals 10. But the question did not ask for just D. The question asked for C plus D. So I already knew C from the beginning. So once I found D, I can add 5 plus 10, and C plus D is 15. Standardized tests have a lot of questions like this. Maybe not necessarily just for these proportions, but even when you're doing different algebra things, they're going to ask you, maybe find x, but then they'll ask you to go back and say, what's the value of 2 times x? And then that would be the answer they're looking for. So just make sure you're paying attention for what the question is asking for. So we had to go back then and add 5 plus 10 to get the final answer of 15. The next one is Theorem 8.9. Again, don't memorize the number. It's called the triangle angle bisector theorem. And this one states that if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other 2 sides. So the red is the ray, and I can tell that angle C has been bisected because of the 2 congruency marks there. So then once that ray bisects angle C, it now splits the side, which is here, into sides, or into pieces or segments whose lengths are proportional to the other 2. So notice I can put the 2 pieces that were split, AD over DB, and then I'm going to take the other 2 sides of the triangle and put that in the other ratio. Now, you can also go and set it up as the side that it's next to. So if you also want to set up the piece here that was split over the side of the triangle it's next to, you could set it up as AD over AC, and then this piece and the side of the triangle that it's next to. So you could also say DB over BC. Again, find the proportion you're going to work with and stay consistent. You can also flip this. Okay, so these are the side that are next to each other. So let's try an example of this one. So it wants me to find the value of x. Now, to make my problem a little bit easier, I'm going to add in another variable. I'm going to call this little piece right here y. Because again, this is the ray that bisected the angle. So here is my ray, and I can tell the angle was bisected by the congruent pieces. So if I set up my proportion like they had in the notes there, if I do the piece that was split, so 10 over y, and then the 2 sides in the proportion 12 over 24. Now, again, simplify that 12 over 24 so you don't have to multiply something really large. Now, let's go ahead and do it the way it is, and then I'm also going to simplify it. So I'm going to reduce 12 over 24, and I'm going to make it 1 to 2. But if I did it the way it was given, 12y, 240, divide by 12, y equals 20. If I do it with the simplified, it goes right to my answer. Y times 1 is y, 10 times 2 is 20. Definitely makes it a lot easier since you're not using a calculator. Now, if you'd rather put it the other way, you can. Now, remember, it didn't ask for the variable I came up with. It wanted me to find x. So now that I found y equals 20, I'm going to add 10 plus 20 to get the value of y. I'm sorry, the value of x, and the value of x is 30. Now, if you'd rather do the 10 over the 12 and then the y over the 24, you can also set up your proportion that way. This is another option. 10 over 12, y over 24. Again, I would reduce this to 5/6 and then multiply 6y equals 120. Divide by 6, and you can still get y equals 20 that way as well. And then remember to go back and add it to the 10. So again, pick the method you're going to use for your proportions and stay consistent.